All right, that's exciting. Watch me set that up. All right, so here's the few formulas, and then we'll see what kind of questions you guys got, and then I'll give the answer key out. There's just a few of them, right? There's the first one we created. Some of you guys won't believe me, even though we went through this. You don't want to use the formulas unless you have to, right? If I give you like a table, if I give you a thing full of poker chips, whatever, you don't need the formulas. It's very different. So OR is basically add, because it's the nice bouncer. Keeps adding more and more people that can get in, right? And then we did the given. I showed you the symbol, didn't I? That's the given. Doesn't mean divide. No, it just means given. A given B. So what's going to be on the bottom? Good. Probability B. And the only way it could also be A is if A was in B. And then from this, we created the AND formula. There's actually two ways to write this, and they're both equal. Does not really matter which way you do this. And so AND basically means multiply. All right. So if you want to, you can just add those to your old formula sheet, bring all that in. You can just keep adding formulas throughout the semester. Keep bringing in those sheets you make. Or you can make a whole different new one. All right. Any questions on those? Any other ones you think you should be allowed? No left out? Yes?
For A and B, I thought you just multiplied A and B.
The only time that's true is, so for example, what's the probability I pick a king out of a deck of cards? How many kings? 452. What if I pick two kings? It wouldn't just be, what's the probability I get a king and then another king? Would it just be 4 out of 52 times 4 out of 52 all the time? No. The next one might change. If I do it without replacement, then it changes, given that I picked a king already and threw it away. So the only time that the probability of A and B is probability of A times probability of B is if they are independent.
Or if it's replaced.
Well, that means it would be independent then. If I do it with replacement, does the next pick depend on what I picked first? No, because it all resets. So with replacement is an example of independence. If I reset the probabilities and do it again, everything's reset, so it doesn't depend on what I picked before. Does that make sense? So the general idea is if they are independent, I can just multiply. What's the only time? Is everybody cool with that? So dear God, don't take the probability of something times the probability of something else and say that's the AND unless you know they are independent. Everybody does that shit, but if I give you a big table and you can just see all the numbers, how do you get the AND? You just see where they intersect and put that number over the total. There's no need for a formula. The formula would still work, but my God, we are not going to do it correctly. It's more complicated than it needs to be. You guys with me? A little bit? No? So the reason formulas sometimes are more complicated than specific situations is formulas have to cover every situation. Does that make sense? This is true for any formula you've ever learned, ever. They look worse than they sometimes are in practice because they have to cover everything. And I think statistics, the first time you see a situation where you're like, I don't even want to know. We did a bunch of probability formulas before we knew any freaking formulas, right? Okay, maybe. I love you guys. All right, maybe. So, what's the only time A or B, the probability, is going to be just the straight up addition of the two? When what's true about A and B? That would mean if that equals this, and that's not there, what does that mean this equals? What would make this go away? If it was 0, when is this 0? If they are mutually exclusive. Stay with me now, come on. So or is basically add. Why do I say basically? Because if I don't know they're mutually exclusive, I got to subtract any I might have counted twice. There won't be any I counted twice if they are mutually exclusive. Okay, maybe.
Can you go over like the mutually exclusive?
Yeah, mutually exclusive just means that if you're in one group, you cannot also be in the other group. They mutually exclude each other. The name is awesome. It's like one of the few times math people, I think we just got lucky. We're like, we didn't mean to make it make sense. Mutually exclude each other. They don't like each other. No, nothing here is also there. So I used to use cat and dog, and then there was Cat Dog, the cartoon, a long time ago. I don't know if you guys even know about that anymore, but it's a period of time I couldn't use a cat and a dog. So now I use rock and ice cream, right? If I have a rock, can it also be ice cream? No. I don't care if it looks like ice cream, right? It ain't ice cream. Don't try to eat that thing. That's gross. It's a rock. It won't do you any good. Maybe? Yes? So that's what mutual exclusive means. If you are one of the things, you cannot be the other thing at the same time. So what's something that's not mutual exclusive? Mammal and dog. They're not mutually exclusive because can you be both? Of course. If you're a dog, you're a mammal too, right? Okay. Is that cool? Is that all right? No? Yes? It's okay if it's not all right. I could.
Yeah, it's good, but like, it'd be easier to understand with numbers, like actual problems.
Not really.
Well,
To be honest, everybody has these, right? This is it for the foremost.
Wait.
Oh, sorry.
One more thing. Okay, yeah,
The reason. All right, so let's do one. Let's. Here's an example, and let's see if you really mean what you say. Of a problem, I can show you numbers. Let's see if you guys get this. So if I pick one card, what's the probability it's club and red? Right? All right, so on one level, the reason why the first thing I said was no when you wanted numbers is because I don't need numbers to know the answer to this is what? How many clubs? What color are clubs on cards? Do you guys know cards? Huh?
Black and red.
What color are clubs? Black. I love you guys. All right, maybe cards isn't good. Let's try it. Okay. Let's go away from cards. Let's say I put 4 bananas and 3 strawberries in a sack, right? And I pick one. What's the probability I got a banana and a strawberry? You
Like,
pick.
If you pick banana and then the next one you pick a strawberry.
How many am I picking?
7.
How many am I picking out of the 7? 1. I pick one fruit. What's the probability I pick a banana and a strawberry?
0.
I know, it's just weird. Red banana. That actually sounds fantastic. Why don't they do Does that sound silly? Is that silly? Yeah, it is silly because mutually exclusive events are going to be in your face. You can't be both. They're going to be remarkably clear. Now, what kind of problem are you going to get? You're not going to get that kind of problem because that should be, it's so easy you miss it. Of course it's freaking zero. I can't get both if I pick one fruit. They'll say, well, maybe it's stuck. Maybe you didn't. No, I pick one fruit. One. Shake that other one off. Right? Can't get a banana strawberry. Not yet. They haven't hybridized those. Right? Not that I know of. I've got to look that up now. Maybe. So what am I going to do to you? Maybe what the homework did. So what am I going to do? I'm going to say, what am I going to do? There's a problem that says, simple like this. T and W are mutually exclusive. Everybody cool with that? What can I immediately write down? What must be true? Yes, the probability of T and W must be 0. Has to be 0. We know that. That's what mutually exclusive means. They can't both happen at the same time. There's a problem just like this in the homework that everybody's doing. Right? And then if I ask you, so if I tell you the probability of T is 0.7 and the probability of W is 0.11, what's the probability of T or W? What's the formula for that? P of T plus P of W minus P of T and W. But what is this? 0. So that is the one time you could just add these together because they are mut-ix. They're mutually exclusive. Not a difficult idea, but like any idea, it requires a little bit of thought to get into it. But if I know they are mutually exclusive, I can immediately write this shit down right there. So a lot of people, there's problems in the homework where they say these are mutually exclusive and just keep reading. You're like, okay, where's the problem? Here's the numbers. Let me start throwing numbers. That first sentence is it. If you miss that, you're going to screw everything else up. That is important because it tells you this. And how could you figure that out if you didn't know this? I don't know. Some of you guys still do it, but. And some problems say, like E and J are independent. What could you write down if I said that? So that's this problem. So what would it be? This one real quick. 0.7 plus 0.11 plus 0. I'm sorry. Minus 0. That makes a huge difference. 0.81. Blah, blah, blah. That was doable. They didn't tell me what the end was, but they did tell me something that told me what the end was. Okay. So what if they have a problem where they say E and J are independent? What can I write down immediately? What does that mean? P of what now? P, probability of? I don't hear the right word. Not E and J. Not or. Yeah, PE, right? Again, this is probably the thing that, and you're all like, whatever, math boy, you know all this math, but this is the thing that kind of gets me the most, because it might just make sense to me, but it seems like it should make sense to everybody. The only way two things could be independent is if one of them happens, right, given J, the other one doesn't care. That's what independent should mean, right? What's the probability of E given J? It's the same as what the probability of E was, because E didn't give a shit that J happened. So of course I'd call those independent. So if they tell me two things are independent, I can immediately write that down. I could also at the same time write this down. What's probability J given E? Probability J, I like it. All right, and I'm tired. Think of PJs. Damn it. And then if they tell you that this is 0.7 and they say, what's P of E? Well, it's freaking 0.7 because it's the same thing. So if you skip over that first sentence where they tell you mutual exclusive or they tell you independent and you don't use it, you're dead. You can't do the problem because you just missed where they gave you the most information. How we doing? Not good. All right, maybe a little bit. Yes.
What about the E and J?
Well, okay. So what would that be? What's the formula for P, E, and J?
The E without E, J?
It's probably of E times probably of J given E, right? Or it's probably of J times probably of E given J. Is that, I'm just using the formula, right? So if they told me this, and they told me this and this, right, so if they tell me this, how can I rewrite this formula right here? If they are independent, what does this equal? Probability of E. And again, that's what I said earlier. The only time you just directly multiply two probabilities to get the end is if I know they are independent. Why? Because if they're independent, this dude stays the same as what it was before I knew that shit. That's it. That's why and is basically multiply, because there might be an adjustment, unless I know they're independent, or is basically add, because there might be an adjustment, unless I know they're mutually exclusive. Okay. All right. So how do you study that? Well, what does mutually exclusive mean? You write it down. If you see it, you know exactly what to write down. What does independent mean? You write it down. If you see it, you know what to write down. If I ask you, show me that these are independent. If that's the question, what do? You calculate this, and you compare it to this. If they're equal, they must be independent. If they're not equal, they're not independent. They're dependent. If the probability changes, when I know that J happened, they must be dependent. That only makes sense. Okay, maybe. So when I ask you that question, and you know I am going to, are these two things independent? If you find yourself starting to write a lot of words, you are wrong. Stop, erase. What's the only thing you can do to show me two things are independent? Show me the given is the same as what it was originally. And just like on the worksheet, just like on the quiz, I make you do all the calculations you have to. You just have to point me back to it. Okay, I like it. Some of you guys hate me even more. Every day, a little bit more. I like it. Try to raise that bar on your hate. Go on, let it flow through you. All right, anything else? Man, you really do hate me. That's all right. I'll get over it. I'll be all right. All right, let me give you this answer key to see if that spurs anything. On this practice quiz, if you tried it, the only one you really need the formulas for are number 4. All right. Yes.
Do you happen to have any of the quizzes with you? Like the
Practice quiz?
yeah.
I didn't bring any more copies, but
Okay.
My office is right there, so after class you can go right there. Okay. You can always just cover up the red writing. All right.
I like it. I like to
Oh, okay. I understand. I'm the same way. All right. Any other questions before we get into new stuff? Everybody knows I'm in my office right before class, right? You guys know that? No? Yes? I love it. You guys are thinking, I get enough of you in class. Why would I want to add another half hour of you, Jeff? I'm like, well, just in case I'm there. At the very least, if you have corrections you're still working on, you can say, can you look at this and see if it looks good? And I'll tell you what needs work. And I'll even help you. If you have time to stay, I'll help you. It's incredible. Because when people make corrections and they get no points back, what sense does that make? None. All right. Any questions? You guys are looking that over? Anything? I like part 2B, the one about Butterfinger and then Twix and then another Butterfinger. If I only have one Butterfinger and I'm doing it without replacement, I keep eating them as I pick them, that's why that comes out to be 0. There's no chance. Kind of makes sense. And like I said, number 4 is the only one you have to use a formula for. Number 1C, that kind of problem, people try to use a formula for that one. Why the hell would you want to? Right? If I give you the table, how do you find ands? You just see where the intersection is. See who's in both sets. So there's going to be a smaller number because they got to meet both requirements. The formula works. They always work. It's just a lot more than you need in that one. Okay, maybe. All right. Not seeing any questions. We're going to forge ahead because we're crazy people. Okay. Little disclaimer. What we're about to do is this. We're going to have a different way for them to give us data. So far, we've mostly been the people that live in the above the ceiling. Drop data down on us. Don't freak out. So far, what's the only way I've given you data to work with? In a list, right? Some kind of list. So there's going to be a different way. If there's a lot of repeats in the data, there's a different way to give me that data. So if I had like 82s and 73s, why would I write 2 80 times and 3 70 times? There's a better way to kind of tell me. Just tell me 82s, for example, instead of writing 2 80 times. Holy shit. You guys semi with me? All right, stay with me. This is neat. What are the 2 most important things to calculate from a set of data? Probably the 2 main things that came out of chapter 2. Right? Because 2 is where we started really calculating shit. What's the most important 2 things to know about any group of data? You can do it. Say again? Sample size, that's good. But what do I use that to calculate? What are the 2? So if I had a bunch of grades in a class, what do you think I'm going to calculate? What's the most basic thing I can calculate? Average. Right? The mean. It gives me an idea of the middle. But if I have 2 classes and they both have an average of 75, what's the other thing that I can calculate that give me a better idea of what the data looks like? The spread, which is also known as the, more formally, Mr. Spread. No. Doctor's, no. Standard deviation. I think somebody said that. Yes. So if I have a set of data, if I know where the middle is, and I know how far the data gets from that middle on average, that's a beautiful summary. That's all I got to tell you. So if I told you there's a group of grades, and the average was 72, and the spread was 18, versus There's another group of grades where the average is 72 and the spread was 10. You with me? Let me write that down. So let's say there's one class, average of 72. And a standard deviation of 18, I think I said. And the other one is 72 with a standard deviation of 10. Which one is it more likely that somebody got a higher grade? What does this mean? This 10, what does it tell me? That's the spread. That's how far, on average, the data points get away. So which one gets away from the average? Which one has data points that get away from the average more often? The first one. I love it. Do you even know what the hell the data points are? But we've already started talking about that, haven't we? I only need is these two numbers, and I have a decent amount of information. I don't need to see all 50 grades or whatever. I just got to give you these two numbers. And then I can start comparing things. Maybe. So, I mean, if I get an average, 72 is not horrible, but it's not great. It's definitely not a great average. It's right next to D. Holy shit. So this would worry me more than this. This one means that there were some people that made really low grades and much higher grades, right? So the really low grades maybe brought the average down. This one means a lot of people were close to 72, which is almost failing, which is almost a D, right? So if I get a low average and a low spread, I'm a little worried. I'm like, oh shit. This one, I don't like that, but this makes me feel better. Because maybe it was like 3 people got 20s, and that's why the average is so low, and that's why the standard deviation is so big. Are you guys starting to see? Okay, maybe. So that's why, no matter how they give me data, I need to always figure out, is there a new way to figure out the mean and the standard deviation? Why? Because they're stupid useful, right? Let me use a better adjective. They're really useful. A little adverb. All right. So, here's the real caveat. So today, the very first thing I'm going to do is nothing that we are ever going to have to do again. So some of you guys, don't just shut down though. What does that mean? I'm going to show you the math behind why the shortcut we're going to use works. I want to continuously remind you of this. Okay. So I'm going to give us a very small set of data because it's easier to work with. But what we're about to do will work for any size set of data. Thank the gods. So let's say this is my data. We can do this, Jeff. Come on. What is it? 1, 3, 5, 9, bam! All right, I like it. Okay. So here's my data. Bunch of repeats in there, right? So how would we just calculate the average? Just tell me, how would we calculate the average? You can use English. Add them all up. Divide by MA. I love it. So I would do, so the mean, so let's say this little population. The mean would be, what's a smarter way to do this? I got 3 5s. Is that cool? It's like what I was saying earlier. 3 5s and a couple 6s. And 4 7s, and then 8. Divided by 10. Nifty. Now right about here is where I lose some people. And again, this is a very small set of data. We're going to be working with much larger sets. So over here is the old way. If I finish this out, how do I keep going? 15, 27, 55, 63, is that right? Look at me go. And then 6.3. My boy can add. All right, no big deal, right? So that's done. And I always say, I know I get people like, well, why are we, you just said it was done. Okay. Here's another way to look at it. Isn't this 3/10 times 5 plus 2/10 times 6 plus 4/10 times 7 plus 1/10 times 8? Is that mathematically, is that all right? Would you ever do that weird shit? No. And we are never going to do that, are we? We're not. This is why the math we use works. Just keep that in mind. Why does this make sense? What is 3 divided by 10? 0.3, 30%. 30% of my numbers are 5s. 20% for there. Oh yeah, right? I like it. This is related to how you calculate your average with somebody like me that has the averages with percentages. Like your tests are 55% and your quizzes are 25%. So, right? So what you would do 55% of your test average plus 25% of your quiz and homework average plus, this is how you calculate the average when there are weights involved. So these are the weights. 30%, blah, blah, blah. It's got to come out the same. So 3/10 times 5, 15/10 plus 12/10 plus 28/10 plus 8/10. So I get 1.5 plus 1.2 plus 2.8 plus 0.8. And I know I'm writing gross and I don't care. If you add all that shit up, remarkably enough you get. Of course you do, right? Because math doesn't care. You do all the same operation, you're going to end up in the same place. All right, now, so what does this have to do with us? What does this mean for me, Jeff? What's my shit going to look like? You said we're not going to ever do this, and you're wasting a lot of time doing something we're never going to do. Jeff, stop. All right, I'll stop. So this is the way. That's the old way. Get away. If they would have given me the data like this, what would go here? What do you think this represents? Probability. So what's the probability I'd pick a 5? 30%, right? Let's probably get a 6. 0.2. Let's probably get a 7. Let's probably get an 8. What's got to be true about this? And how would you represent what we just did in symbols? What did we just do? We just added up the p of x's. Well, what symbol means add up? It's like sigma, right? Can we stop for a second? That's the thing we knew forever. We know that we add all the probabilities, it's got to be 1. Or close to it in case I round it somewhere, but